Okay, class. So everyone can hear me, can see the document.
Yes.
Can see the document. Okay, good. Okay, so let's we recap again. So electric field, we learn about force, F equals to K Q1 Q2 or R squared. Okay, then we talk about electric field strength. F equals to K Q R squared. Electric field strength is force per unit charge, positive charge, vector quantity. Then third, electric potential, KQOR, work done per unit positive charge. Don't forget to say the word positive. Work done per unit positive charge, KQOR. Then finally, we done about electric potential energy, KQQ over R. The formula is not here, but the day I show you. Then finally, we discuss about the relation between electric field and electric potential. Electric field is what? Negative of the electric potential. Potential gradient, electric potential gradient. Okay. So I believe that day we did. So then we talk about the dissimilarity and differences between gravitational and electric field. And this is the important graph you need to remember. Okay, in the sphere the field is 0. Okay, but the potential is maximum. Okay. Okay, then we talk about tutorial. That day we did tutorial. Then we have a question 4 to 5 to discuss today. Okay, so anyone tried 4 and 5? Any problem? Able to get the answer? Okay, so if you don't have, let's be. I hope you can do these 2 questions because the answer is there. Give a try. Okay, so at the back also you have lots of questions for you to try. Okay, so today we're going to do the partial. We go ahead with the partial. Okay, this is the past question. Okay, this is a past question, so I need your feedback when we do the questions. Okay, so electric field is normally together with capacitance. Capacitance is another topic we're going to do after this. Okay, today later. So that's why we have to select some questions which is not without capacitance. So some questions we only can do partially. Okay. Okay. So first, the question I want to select is these all are capacitance. Okay. We can use spark because okay, this one. June 03 question 4. Okay, June 03 question 4. Have a look as we discuss. In a particle experiment, high voltage is created by charging an isolated metal sphere as illustrated. So you have a metal sphere. The sphere has a diameter of 42 centimeter and any charge on its surface may be considered as it is concentrated at its center. The air surrounding the sphere loses its insulating property, causing a spark. And the electric field exceeds 20 kilovolt per centimeter. When the electric field strength exceeds 20 kilovolt per centimeter, spark happens. Okay. Our question is, by reference to an atom in the air, suggest the mechanism by which the electric field causes the air to become conductive. 3 marks. They're asking how spark happens. What is the mechanism behind why the spark happens? When you have a sphere which is positively charged, the air at the beginning is neutral, but later spark happens. Why spark happens? Explain in 3 marks. So how are you going to explain that? So what do you have to say? What causes spark? So first you need to talk about what happened to the air particle. What happened to the air particle? So because the sphere is positively charged, the nucleus repelled from the sphere. The nucleus of the gas particle repelled from the sphere, but the electron in the air particle attracted towards the sphere. That's one mark law. You have to see what is attracted, what is repelled in the gas particle. Okay, the nucleus is repelled, the electron has been attracted towards the positive charge plate. Okay, then what do you say? When the electric field gets stronger, what happened? The electron will be strip off, will come out, will strip off from the atom. Okay, the electron will strip off from the atom because the positive charge gets stronger. So the electron attracted more towards the sphere than the nucleus. So the electron will strip off from the atom, then causes the air become what? Air become ionized. And ionized. Okay, it become ionized. And therefore spark will happen. Spark will happen. The electron move down towards the towards the sphere and causes the spark to occur. So by reference to the atom of air suggests the mechanism by which the electric causes the air to become conducting. First, you have to say the nucleus is repelled from the sphere because like charges. Electron is attracted towards the sphere because unlike charges. One mark. Then you say when the electric field gets stronger, the electron attracted more towards the sphere than the nucleus. Therefore, it will strip off from the atom, causes the air to become ionized and therefore conducting. Okay, this results spark. I hope that's the idea should be in your mind to explain this. Any questions? Okay, so it's a fact to remember. Very common they ask what causes the air ionizing. So first you have to say nucleus and electron as a different type of forces towards the positive sphere. One is attractive, another one is repulsive. Then you say when the field gets stronger, the electron strip off from the atom, causes the air become ionized, therefore conducting, causes the spark. Okay. Okay, next. Calculate for the charged sphere when the spark is about to occur. Okay. They say the spark will happen at 20 kilovolt per centimeter. They're asking what charge on the sphere will causes the spark to happen. The sphere, the electric field is 20 kilovolt per centimeter. Spark will happen. They're asking what is the charge must be on the surface. What formula must be used in this formula? In this question? 3 marks. Anyone? Radius given? Radius given. Radius is 42 centimeter. What formula do you use? So you have what? You have force formula, you have electric field strength formula, you have potential formula, you have potential energy formula. These are the 4 formulas you have. So here, what formula do you use to find the charge? Because electric field strength is given, so you must use the electric field strength formula. What is the electric field strength formula? Electric field strength is force per unit positive test charge or Q over 4 pi epsilon naught R squared. So the electric field strength at the surface should be how much? 20 kilovolt per centimeter. So it's a trap. The trap is per centimeter. I think you have to convert to meter. So per centimeter, you convert to meter, you do what? Per centimeter, volt per centimeter. Per meter, the value get bigger or smaller? 1 centimeter, 0.01. It become bigger, right? So here you need to put 20,000 volt per centimeter. Can you change to volt per meter? Change volt per meter. When you change volt per meter, what do you get? The value get bigger or times 100 or divide by 100? Times 100 or divide by 100? Volt per centimeter.
Times 100.
Times 100. So 20,000
Times 100.
times 100. You get volt per meter should be equivalent to the charge we are looking for 4 pi epsilon naught. R should be how much? 42 centimeters. So we write 0.42 meter square. Then we work out the charge.
Sir, the diameter is 0.42, so the
Oh,
radius will be 0.21.
one square. So you should get the answer here. Anyone? What's the charge you got? The 1 over 4 pi epsilon naught, you can take it as 9 times 10 power of 9.
So what was the radius?
The radius, the diameter is 42, right?
Oh,
the diameter is 42 centimeter. So yeah, then the radius is 21. So put in meter. So yeah, so you get the charge. Okay. So important is the flow. When you read this question, do you figure out this is the formula to be used? Do you realize the volt per centimeter, the meter need to be changed? Centimeter need to be changed. Do you realize the given is the diameter, then we have to use the radius 0.21. Okay, if you got these 3 points correctly, then good. Okay, one you fail to identify, then the answer going to be wrong. Okay, the conversion always there like a virus for physics. Every time, every paper, without fail, conversion will come in. You have to check is it need a conversion or not. And here diameter, just now I made a mistake. Should be a radius. Okay. So that's the Q. You get the charge. Okay. As I said, I'm not interested with the answer. It's fine. You can calculate and you can get the answer. My main point is the flow. Okay. Assume we know the charge already. Okay. Let's go ahead with the second part. How do we do this? What is its potential at the surface? How much the potential it has in the surface? So what formula? Of course, the potential formula. What is the potential formula? Is work done per unit positive test charge, which leads you what formula? Q over 4 pi epsilon naught R. As I said, I used to tell KQ over R, but don't write this. K you replace with 1 over 4 pi epsilon naught R. Okay, so this the formula must come to your mind. It's potential at the surface. So Q, the Q you got on the top, place here, must be in column. And R again should be what? How much? Be 0.21. Okay. Then you get your answer in joule per column or can be volt. Okay, so those, when I say it's potential, those who realize the formula V equals to Q for pi epsilon naught R, good. That's the first step. Other than that, it's okay. Other than that, it's just substitution. Okay, any questions so far? The flow? Get the flow, Okay. Next. Okay, see. Under certain condition, a spark sometimes occurs before the potential reaches that calculated in V2. Suggest a reason for this. Suggest a reason for this.
Mm,
Spark sometimes happens earlier than the potential calculated here. Why? Because what is the potential? Potential is K. Okay, I make it easier. KQR. So we know for the radius of 0.21, that is the potential required. Let's say potential required. Let's say I put a number. Let's say 1000 volt required. Okay. Sometimes the spark happen less than 1000. Why? Everything is in this formula.
oh. Wait.
If a lower voltage, let's say, and a low voltage also spark happens, means what? The radius become
Bigger.
bigger. Yeah, radius become bigger. Bigger or smaller?
Smaller equals larger.
Yeah. Big radius. Big radius give a smaller voltage, but no, big radius. So the problem is the sphere. The sphere is non-uniform. The sphere is not a perfect smooth curve. Maybe the surface is a little rough when you go to a microscopic level.
Ah.
So when it's rough, if it's rough, a little rough, the radius is this diameter. The radius. Okay. Radius. Maybe the the radius is changing. The radius is changing. So spark can happen at a or not spark. Sorry, not the lower voltage lah. The spark have to happen at 1000 volt. Okay, the spark should happen at a 1000 volt. Under certain condition, the spark sometimes occurs before the potential reaches that calculated. This is the volt, volt KQR. Because the radius is the radius is big now, big radius. So the answer given, you say what? The sphere is not smooth. Not smooth. The sphere is not smooth. Okay, the sphere might be not smooth. One reason. Another one reason, what we can say is blame the K. The K. The K is actually what? K is 1 over 4 pi epsilon naught. Okay, epsilon naught. This formula epsilon naught is only for what? If it's a
Vacuum.
vacuum. If it's got air, the humidity of the air can change the epsilon naught. So the K value will change. So you said the humidity of the air can affect the spark happens earlier. Okay, the sphere not smooth. The humidity of the air can causes the spark to happen earlier because humidity of the air change the epsilon naught. The epsilon naught get, if I'm not mistaken, will get bigger. Will get bigger, but not in your syllabus. But they indirectly ask. Okay, but sphere not smooth, radius change, so spark can happen earlier, or humidity of the air. Okay, this is one complete question about electric field. Any part you don't understand? Okay, so let's proceed. Another one question. Okay, this is it's also a good question, but I think I go for the Juno 5, number 5 first. Yes, please read the question. An isolated conduction sphere of radius r is given by the charge positive q. This charge may be assumed to act as a point charge situated at the center. So the potential varies with x is like this. Okay, inside the voltage is constant, outside it reduces. Now the question is, state relation between electric field and potential. What is the relation between electric field strength and the potential? Anyone? Electric field strength is what? Electric field strength is,
V over D.
but how do you put in words?
Voltage
Electric field strength is
distance.
negative of the potential gradient. Electric field strength is negative of the potential gradient. That's your electric field strength. Your E is the negative of the potential gradient. You can write this formula. Okay, good. Those who are figure out this, E equals to negative of the potential gradient. Okay, next, E. Using the relationship in A, sketch a graph to show the variation with the distance x for the electric field strength due to the charge positive Q. Okay, for a positive sphere, just now we did this earlier, right? Positive sphere, how the electric field looks like. So you draw a straight line here, border. So within R, the field must be 0. Then the field get positive, then go down. It goes down. Okay. So remember, sometimes they check this, if this is E, when it comes to 2R, should be how many E? How many E? Anyone? Should be quarter E, right?
Oh, quarter, yeah.
Because E is what? Yeah, KQ over R squared. What? It's R squared. So quarter E. And 3R should be like E over 9. Okay. Real exam, if they give these numbers, the 2R, 3R, 4R, don't simply draw a curve. At 2R, your E must drop to E over 4, roughly. So you do estimation lah, like E over 4, then you mark the point. Yeah, mark the point, this E over 9. Then you draw the curve. Don't simply draw a curve like this. You might lose mark because it's 3 marks. 2 marks, I think, for the shape, 1 mark for the value here. Okay. So electric field strength inside the sphere is 0. Okay, potential is maximum. Okay. Okay, so that's the one question. Any question about this? No question. Okay. I skip capacitance. Okay, this one. You know, 6, question 5. Okay. First question. Conduction sphere of radius r placed at air. It is given by the charge positive Q. The charge may be assumed to act as a point charge situated at the center of the sphere. Define electric field strength. Anyone? Praveen here. Praveen?
Yes, sir.
Praveen, can you define what is electric field strength?
Okay, sir. Give me a minute, sir.
What is electric field strength? What over what? Electric field strength. This is your AS IDA 2, right? It's your AS IDA 2. So electric field strength is what over what? Yeah, Praveen, force per unit, positive, charge. Force per unit, positive, charge is your electric field strength. Okay. So if you have a field here, how strong is the field? The amount of force exerted by the charge divided by its charge, positive charge. Electric field strength. Okay, 2. State the formula for electric field strength E at the surface of the sphere. State the meaning of any other symbols used. State the formula for electric field strength. So electric field strength formula is E equals to, for electric field strength for a sphere, for a sphere. So of course we know it's F over test charge. This is a common formula, but in reality is what? Q over 4 pi epsilon naught R squared. This is the formula. And explain what is Q and R represents. Q is the charge possessed by the sphere, and R is what? You say the radius of the sphere. Radius of the sphere. Okay. So this is the introduction. Next, B. Okay, read the question. Have some idea what formula to be used, what to be substituted. I'll give you 1 minute. So what formula? Asking what is the maximum charge can be stored in the sphere. Okay, the field electric field strength given and the radius is given. So E equals to Q over 4 pi epsilon naught R squared to be used, because you know the E and you know the R, you can work out the Q. Okay, you can work out the Q. As usual, 1 over 4 pi epsilon naught, take it as 9 times 10 to the power of 9. Any conversion need to be done? No conversion. So you can work out the charge. Okay. So any problem you face here, those who figure out the equation and how to calculate, good. I think not a tricky part. It's straightforward because they already asked you to write the equation on the above. Okay, next. What is the potential at the surface of the sphere? What is the potential at the surface of the sphere? They're asking for V. So what formula? Haris, can you tell me the formula? Haris? Haris here. Haris not here. Okay, what's the formula? Q over 4 pi. Q over 4 pi epsilon naught R. This formula must come to your mind. V equals to Q over 4 pi epsilon R. Q know already. R you know earlier, the on top, so you can get the answer. The answer you got is what you need? Joule per coulomb, or you can write volt. Okay. So this is potential. This is a very good question. Okay, class. I need to tell you another one thing. Okay, I forgot to mention this in the earlier description when we do this this topic. You see, if you have a positive charge here, you have a positive charge here. Okay, so this is 0 from here. It's moving a distance of r. It's r. From here, I want to plot E versus R graph. And I want to plot V versus R graph between these two positive charge. There are only two shapes available. I tell you, there are only two shapes available. Something like this. First one. Another one is like this. Okay, now tell me. E versus R, V versus R. For E versus R, which graph do you think should be suitable? 1 or 2? I'll give you 1 minute to think. Two positive charges. In between them, which quantity can become, got chance to become zero? Let's say choose one point here, along this point lah. Which quantity have a chance to become zero? The electric field strength has chance to become zero, or the potential has chance to become zero between the positive charges?
What?
Electric field strength or the potential? Because I want to find the effective electric field strength between them, you know.
Yeah.
You see the on the left one, at this point,
Yeah, on
the
electric field strength,
electric field strength becomes a chance to become zero. Why?
because both are repelling each other.
Correct. One give electric field strength at this point is to the right, E of one. The electric field strength of the two is acting to the left. E2 is to the left. So there'll be a point where the E2 and E1 is same. So the effective E, that this is like the resultant E. Now the resultant E become zero. Okay. So remember, the graph for resultant E will be like this. Okay. Why positive at the beginning? Because for one, the field is going outward. So to the right, we assume it's positive. There'll be a point where the E becomes zero here. Okay. Then after that, when you go closer, okay, the field become more negative because this field becomes stronger. It's to the left, so it become negative. Go negative. Okay. And this cutting point, right? This cutting point, okay, where the E becomes zero, if it's more to the right, close to the second sphere means second sphere has a less charge or more charge?
Huh?
See that the cutting point I put close to the second sphere. That means the cancellation happened close to the second sphere. The second sphere possess less charge or more charge compared to the first one?
Less charge.
Less charge. For example, this is positive 5 column, this is positive 2 column. Yes, the cutting point where the E becomes zero happens close to positive 2. If they give both positive 5, you must make sure the cutting point happens at the center. But whatever it is, for like charges, the field graph going to be, the effective field graph going to be like this. Okay, positive become zero, become negative. Okay. So number one goes to electric field. Okay, how about potential? Do potential can cancel between them, between any point? No way, right? Because potential is a scalar quantity. Potential caused by 1 is positive. Potential caused by 2 also positive at that point. Because V is what? KQ over R. The Q sign need to be included, both positive. So you know lah, V1 plus V2 is the total V. V1 positive, V2 also positive. So total V will become positive, never cancel. So, but it will get a minimum value lah. It will get a minimum value. Go to a minimum value and come back. Okay, like this. So the curve going to be like this. Okay. Okay. Remember, please include in your notes. These two graphs. Okay. These two graphs. The first one and the second one for like charges. Okay, the field between the potential between two like charges, positive, positive. If it's negative, negative also give the same graph. Give the same graph. Okay, give the same graph. Okay, maybe you can put it down, but it's going to be positive, then later become negative for electrical. Okay, please include these two graphs in your notes. Very important. Okay, now can you draw the E versus R and V versus R graph for unlike charges? One is positive, another one is negative. Unlike charges, how the E versus R, V versus R graph look like? This same two graph will repeat again, but which will be for which one? if one positive, one negative, what quantity can be zero in between them? E or V? Which electric field strength going to be zero in between them? The resultant electric field strength or resultant potential becomes zero in between them? Any one point line between them. Which can be zero?
V.
Yes, V becomes zero. Got chances V becomes zero. So V need to become zero in between. So these two graph, right, going to be the other way around. Now the V going to be like this. Okay. Like this, huh? So for positive, negative, the E versus R, the V versus R, the V will become like this. E will become like this, opposite. Again, the cutting point here, the V, depend to the which has a greater charge. I'm drawing such a way that greater charge is for the one. Okay, please improve this. This is for unlike charges. So unlike charges, V has chance to become zero in between them. Like charges, E has a chance to become zero in between them. Okay. Okay. So why I'm telling you this? Because the next question. Okay. We go back to the question. You now only go for June 7. Okay. Read the question. Two charge point A and B separated by a distance of 6 centimeter. The variation with the distance D from A of the electric field strength E along the AB is shown here. Or they say the field change like this. Okay, tell me. They never tell about the nature of the charge. The E was like this, electric field. Question is, an electron is emitted with negligible speed from A and travel along B. State the relation between electric field strength and potential. What is the relation between electric field strength and potential? Electric field strength is negative of the potential gradient. Electric field strength is negative of the potential gradient. Put in words lah. Electric field strength is numerically equal to negative of the potential gradient. Now, the area below of line represents the potential difference. Say the area under the graph is potential difference. Correct, right? E equals to negative dV dr. Okay. V is what? You know, your maths knowledge is an integration of E dr, right? Integration means what? Integration is what? The area of the graph, right? The area is your integration value, right? Which is the V. Maths knowledge lah. So here they help you. You see the area below the line represents potential difference V. Potential difference, changes of V lah. Final V minus initial V. Use figure 3.2 to determine the potential difference between A and B. So what do you do? Here they already guide you lah. What is the potential between A and B? So what do you do? You find the area. How are you going to find the area? You have to count number of boxes. Maybe you can draw a straight line here. Treat it as a what do you call as a trapezium. Okay. Then then you calculate this area as another trapezium. Okay. You subtract this area. For the first trapezium, subtract this area for the second trapezium. You get the total area. Okay. Very difficult to find one by one the number of boxes. You draw a trapezium, okay, but the area you're going to calculate by using a trapezium is slightly higher than the actual area. You minus this small area lah. Calculate the number of boxes. One small box, how much? Calculate the number. This is 1 times 1. So you get the area of 1. So you minus them. Okay. So it's tedious. It's tedious to calculate the, what was it? This one. Determine the potential difference A and B. It's tedious to calculate the area. So you get the answer. Volt. It's 4 marks. A lot. Marks for, yeah, 4 marks the entire thing. Okay. So you go to the, so that's the area, finding the area. Okay, I assume you know this value. We go to the part C. As I said, the important is the technique. How are you going to work out? C. Assume you know the potential difference already. You know the potential difference already. You know the A moving to B. Okay, the changes in potential, you know, which is final B minus BA, you know already. This is your value lah. Okay. Use your answer in B. Calculate the speed of the electron as it reaches the point B. How are we going to do this? Calculate the speed of the electron. The electron will be slowing. The electron, was it from rest, or we check the electron first? How the electron was moved? An electron is emitted with a negligible speed from A and travel along B. So electron move from A, negligible speed means we assume that it's in rest lah. Move to B. So the electron has been accelerated. Okay. So this is the electric field graph. Okay, now they're asking, use your answer in B, calculate the speed of the electron as it reaches the point B. The electron move from A to B. So tell me, the electron passes through a various of electric field strength. The E graph just now we saw is what? The E graph is going down and going up again. Okay. So when the electric field is going down, electric field is, but entirely is positive lah. The electric field is positive. Positive means what? The electron is pulled towards right. The electron is pulled towards right with the positive force. Okay. If E gets smaller, when E gets smaller, how about the force pulling it to the right? Gets smaller or bigger? When E gets smaller.
Oh.
E equals to, how E and F related? F equals to QE, right? So when E gets smaller, the force gets smaller, force get smaller. So the electron move to the right, moving in a smaller force. After point A, the lowest, E increases again. That means the force increases back. But the electron keep on moving to the right with various of acceleration. Force gets smaller, the electron accelerates slowly, but still moving forward. Okay. Then at A, E increases, so acceleration increases further. So throughout the movement, the electron gain what? Gain kinetic energy, right? Gain kinetic energy. Okay. So the gain in kinetic energy equals to what? Work done by the field. This is the first point. The gain in kinetic energy of the electron is work done by the field. So gain in kinetic energy is what? Half mv squared minus half mu squared. Because it starts from rest, half mu squared is 0 lah. I don't have any more. So just half mu squared, we're looking for the V. Work done by the field, what formula? Anyone? The field does work. What is work done by the field? Something times something. Anybody?
Electric potential times the charge.
Yes, very good. The charge times the changes in the potential. Because move from one potential to another potential, the work done by the field is QV. QV converted to gain in kinetic. Or can say loss in potential also can. I always say potential, kinetic, and work, they are related. If work you got 20 joule means, positive 20 joule means, the potential is positive 20 joule. Kinetic is negative 20 joule. You lost kinetic. Okay, so here, so put the charge. What charge is supposed to be used here? Anyone? What charge you have to use here? Charge of the electron. Charge of the electron to be used. So see from the front page from the question paper, 1.6 times 10 power negative 19 multiplied by the V. The changes of V which you calculated earlier. Place inside here. And the mass of electron, again, go to the front page, check the question in the exam question paper. For the mass of the electron, you can work out the V. Okay, this is the flow of doing this question. Okay. So the important is those we figure out this. Gain in kinetic energy is equals to work done by the field. You are in a correct track. Those who got this idea first, and you look at this question. And next step, the work must be Q changes of V. Is equals to gain in kinetic energy, half mv squared. Half mu, u is 0. So you can find the V. And the third trap is, you should know the charge and mass is charge of, and mass of the electron. You need to get it from the front page. Okay, what J is this? This is your Juno 7. Okay, for time being, let's see, we go for the Juno 7, the mark scheme.
So that means that when electric field strength is decreasing, given at left it's positive, right is negative. That means that when it goes, when the electric field is decreasing in strength, that means it's gaining kinetic energy.
Yeah, still gaining kinetic energy.
But when it is increasing again, it is gaining potential energy.
You see, the E versus R, right?
Yes.
E versus R like this. Okay, electric field is positive.
Yes.
Yeah, negative, correct?
Yes.
So electric field positive means what? The field is maybe to the right. The field, we take it as positive. So the field is to the right. Okay, let's say. Okay.
Okay.
So I can't say. Let's say the electric field is already one directional. The electron is moving. Let's say the force. So because the field is throughout from A to B is one direction, the force experienced by the electron also always must be one direction.
Yeah.
So when the electric field get lower, the force pulling it forward gets smaller, but the force doesn't turn direction yet. The force never changed direction yet. If force change direction means E get negative. When E get negative, then we know the force is changed direction. Okay, so throughout this movement, the force is to the right?
Yes.
So the electron will, but the force is not always same lah. Getting weaker and getting stronger back. So the electron keep on increasing its kinetic energy from A to B. Not even once the kinetic energy stop decreasing. It just keep on rising. Because the force is one direction.
But for example, like if it moves from a positive charge to a negative charge particle, that means that from the positive to the middle, from the positive charge to the middle, the electron will gain kinetic energy, right?
For example, you see here, you have a negative here, you have a positive here.
Yes.
Okay, you have an electron here.
Yes.
So throughout the electron move from here to here, this is your point A to point B.
Okay.
Throughout the movement, the kinetic energy keep on rises one.
Yes.
Because keep on rises, never slows down, right? Always rises. So from A to B, the electron kinetic energy just continuously rises, never decreases. Why? Because the force is directed to the right. The force never directed to the left. Because if the force directed to the left, then the kinetic energy will drop, right? And because the force is always one direction to the right, the electron just keep on increasing its kinetic energy, but in a different rate because the force is changing. The magnitude of the force changing. The direction of the force always to the right. So the kinetic energy keep on rises. You can't say kinetic energy dropping. Kinetic energy never drops. Kinetic energy continuously rising. Why? Because the force is to the right always. Why the force is always to the right? Because the field is always positive. When the field become negative, then the field direction change, force direction change. Then the electron will start to slow down. Number one, can understand?
Yes.
Okay. Okay, look at the, which question is this? Juno 7. Yeah, this is the answer. This answer. Just now was which question? Juno 7, right? Yeah, this one. Yeah, this is the working. You see the working here, number C. So the kinetic energy of the gain in kinetic energy of the electron, actually half mu squared minus half mu squared, but u is 0, so they never include that. QE. The V is changes in potential, so they get the final. Okay. Any question from this? Okay, so let's go up. Juno 7, right? Okay, next. Used to determine the value of d at which the electron has maximum acceleration. From this graph, let me rub this. Okay, can you tell me at which d the electron has a maximum acceleration? How define which d as a maximum acceleration? If acceleration is maximum means what must be maximum? How acceleration related to E? Anyone?
Force.
Can you write a formula? Yeah, force, yes. E is F over Q. So yeah, related to force. Acceleration related to force, but force related to E, right? So when A max means F max. When F max means E must be also max. So when E max, force max, acceleration is max. At which D? Acceleration in max. So check this graph, check where the E is max. E is max when the D is 0. The D 0, E is the max, 15. So answer is what? Answer is when the D is 0, when the D is 0, A is max. Why? Because E is max at D0. Any question? I hope you understand. So the answer Oh, here is 0 centimeter. Okay, next 2. Read the question. Try to understand the question. Without any further calculation, describe variation with distance d of the acceleration of the electron. 2 marks. Without any further calculation, describe the variation with distance d of the acceleration of the electron. They ask you to tell about acceleration. Is it increasing, decreasing? Is it decelerate, accelerate throughout the d? So we go back to the graph. Can you explain? How about acceleration? Acceleration is very high at the beginning. It accelerates with high acceleration. Then what happened to the acceleration? Acceleration decreased to what? Acceleration decreased to 0, and the d is about what? About 4 cm. And the acceleration increases again. It accelerates again. It accelerates again in the same direction. So acceleration decreases, becomes 0 when d is 4 cm. And after 4 cm, the acceleration increases again. Throughout A to B, the electron continuously accelerating. Correct? Okay, let me check the answer. Yeah, acceleration decreases, then increases. Some qualitative analysis, acceleration becomes 0 at 4 centimeter. Yeah, that's the 2. Okay. Okay, guys. So, any questions from here? Okay, so you have variety of questions. You have variety of questions here. So please give a try to understand this topic. Okay, so this is what this is the final part of this topic. So you have plenty of questions here to do. You have questions at the back of the paper, back of the word notes. Also, you have some questions for you to try. Okay, so your part is 2 more questions, understand it. Okay, so I wrap up with this topic today. Okay, so I give you a short break, maybe 5 minutes, then we continue with the next topic.
Okay.
Is it okay? 5 minutes or 10 minutes. Okay, so we take a break, then we start with a new topic, topic 8, because today is 2 hours, right? Okay, so now it's time's what? 12:02, right? So I give you a break first, maybe around 12:10, 8 minutes. 12:10, I see you back. Okay? Okay then. So we stop for a while.